Hi all, as you can see today we shall start pressure exerted by liquid. So this is the lesson of class 8 of theme 3 and this is of unit 2. Theme 3 and unit 2. So pressure exerted by liquid, from the name you can imagine what is the topic of that chapter. Okay, so let's prove this pressure exerted by the liquid by some experiment. Okay, first of all let me tell you this is an experimental process. This is of course no need for examination, but the fact you should know that on which factor the pressure under the liquid depends. Okay, so let's say we are taking a tube. This is a tube and a rubber balloon, let's say, is tied just behind it. A rubber balloon is tied behind it. This is a rubber balloon. Okay, and now we are pouring some liquid in it. Suppose this is the liquid. Then we can see the balloon is like this. Okay, the balloon is just like this. We are pouring some more liquid. Let's say the liquid level is now up to this extent. Then we can see that the balloon will become little bit bigger. So how this is become bigger? Because someone is basically giving force from inside. Okay, so what we can see from here? We can see from here that if we increase, basically when the balloon was small, then there was a certain amount of pressure. Now when the balloon is become bigger, then the pressure will increase. That's mean at first the height was up to this extent, but now the height is little bit bigger. So we can say that the pressure that is proportional to the height. The pressure that is proportional to the height. Is it clear? Now let us do another experiment. Let's say here is another measuring cylinder or tube, and there is another balloon. And this is stretched up to this extent, and I am giving some water in it. And the balloon is like this. I am taking another tube of same volume and taking a same balloon here, but instead of water, let's say I am giving another liquid. Let's say some oil. Okay, I am giving some mustard oil up to the same level. Then what I can see? I can see the balloon is little bit bigger than the previous one. Now we tell me what is the difference between water and this oil. Basically the density of oil is greater than the density of water, and as its density is greater, so it is giving more force, better to say more pressure here. So that's mean we can say pressure that is also proportional to the density of the liquid. So now if you combine these two, what you will get? That pressure that is proportional to the height and density. So we know this is a proportionality sign, so we must have to bring a constant. That's mean pressure that is equal to a constant g I am bringing as proportionality constant, and this g is known as the acceleration due to gravity. Acceleration due to gravity. Is it okay? And h here and d here. Now I am writing the most familiar form, P equal to H into D into G. So this P is the pressure under liquid. Now I am introducing each of the symbol, where P I have taken as the pressure. P is the pressure. H is the height. Height of what? Height of liquid column. And G is already told, this is the acceleration due to gravity. Okay, and another thing, D, that is the density of the liquid. Is it okay? So if you apply this formula, that's mean pressure equal to height into density into acceleration due to gravity, then you can find the pressure under water or under any liquid. Okay, before that, what is the value of G? The value of G in SI, this is 9.8 meter per second square. This is in SI unit. You have to remember this value. You may say, sir, can't I write 10 meter per second square? Basically 10 meter per second square is sometimes considered for the simplicity of the calculation. But I am expecting 9.8 in examination if 10 isn't given. Okay, so this is the value in SI, and the CGS, the value of G is 980 centimeter per second square. 980 centimeter per second square. And in if you made the approximation, then it will be 1000 centimeter per second square. Whatever, this is the value of G. Now let me give a real example. What type of example? Let's say this is a pond or a lake or something like that. This is a lake or a pond. Okay, and suppose this is the upper surface of water. Okay, and let's say these are some trees are here and someone is sitting here. Okay, now you want to measure the pressure here. So what will be the pressure here? To measure the pressure, first of all you have to measure the density of water. Okay, then you have to measure the height, or better to say the depth. Okay, then you have to multiply this H, this D and the G, that's mean this value, and by that way you can measure the pressure under water. But there is one thing extra, and for in your class that is not necessary of course, but there is one thing extra. The pressure you will measure by this process will be little bit greater than that. Why? Because air is here, the air column is here, the atmospheric air column is here, and that will give some extra pressure here. Okay, and for that the value of pressure at this point, let's say P, will increase. Is it clear? Now, as the chapter name is pressure exerted by liquids, instead of liquid, if I say fluid, F-L-U-I-D. Now you may ask me, sir, what is the difference between liquid and fluid? Liquid, what is liquid I know, but what is fluid? Fluid means which flows, that is known as fluid. Can you give me example of fluid? Of course you can give, I know. So one example is liquid, any type of liquid, and another example is gas. Gas also is a fluid. Okay, but when you are calculating pressure due to gas, of course the process will be the same, because this is pressure exerted by liquid, but better to say this is pressure exerted by fluid. Okay, now let's say we are on the surface of the earth, and the air is, let's say, up to this extent. This is the surface of the earth, and the air, let's say the atmosphere is up to this extent, and I am taking the atmosphere up to 10 kilometer. Let's say, I know it is more greater than that, let's say 1000 kilometer. Now how to calculate pressure here? This is very simple. This is at H, take density of the rho as 1.00 something, that is in your book, and G is given, so you can easily calculate the pressure, and you will find the atmospheric pressure P naught, that is equal to 1.013 into 10 to the power Pascal. Is it okay? So this is the pressure. Basically we know this is the unit of the pressure. Is it okay? Okay, so let's go to the next topic. Oh sorry, this is 10 to the power 5. Sorry, this is 10 to the power 5 Pascal. Okay, whatever. So let's go to the next topic. What is the next topic here? Suppose I am keeping another tube here, and here is another pipe, let's say, and there is a special system, and you are tying a balloon here, okay, and if you just fill the pipe with water, you will find the balloon here also, the balloon will be bigger when the than the state when the tube was empty. Is it okay? That's mean the liquid giving pressure here also along this direction. We know the liquid was giving pressure downwards, here the downwards, but here the liquid is giving pressure along this direction. Okay, this type of pressure is known as the lateral pressure. Okay, and you will find if you more the depth, the pressure will be more. If you more the depth, the pressure will be more. Basically, what type of pressure it is, it doesn't matter. Let's say this is a liquid. I am keeping something here. It is this type of pressure. If the pressure is from downwards, if the pressure is from this side or this side, that doesn't matter. Only one thing matter, that what is the height from the surface of the liquid. What is the height from the surface of the liquid? Suppose in this case you want to calculate the pressure under the box, the pressure under the box. So how you will calculate? Will you measure this height? No, you will not measure this height. Rather, again you have to measure the height from the surface of the liquid. Here also you have to measure the height from the surface of the liquid. So what type of pressure, it doesn't matter, whether it is lateral pressure or upward pressure or downward pressure, it doesn't matter. You have to measure the height from the surface of the liquid. This is the most important thing here you have to keep in your mind. Okay, for lateral pressure there is a question in your book. You will find that the walls of the dams are made very thick. The walls of the dam, you will find the walls of the dam are made very thick. Why the walls of the dams are made very thick? Because we know this is suppose under a lake. So when are you going under the lake, the height is increasing, right? The height is increasing. As the height is increasing, the pressure will also increase. That's mean to oppose more pressure, the wall must have to be thicker than the upper side. Is it okay? And this is the cause. And a nice picture is given in your book. I can show you. So this is the picture already is given in your book, right? Okay. Next, basically you will find another thing, and you have noticed many times, okay, that water seeks its own levels. Oh, another thing I forgot. Already I have told you the density of water. The density of water you have to remember here, that will not be supplied. Okay, so the density of water we know that is 1 gram per centimeter cube. Already we have discussed a lot about it. This is in CGS, and 1000 kg per meter cube. This will be SI. Okay, and with that one extra thing is here, you have to remember this, the atmospheric pressure. Okay, though on the next class we shall discuss about this atmospheric pressure on the next class, of course, on next week, and that will be a special topic on pressure due to the gas. Okay, or a special lesson on atmospheric pressure. Is it okay? Now let's concentrate on today's lesson. We know that any liquid always seeks its own levels. Any liquid always seeks its own levels. Suppose there is no airflow, then will the liquid be like this? This is the water surface, let's say. Have you ever seen the liquid surface like this? Okay, no, we have never seen. Why? Because if you consider a single level, suppose this is the level under the lake, we are considering this is the level. So always for a single level, the pressure on this plane always be same. The pressure on this level always be same. Let's say I am taking the pressure here as P1, the pressure here as P2, and the pressure here as P3. What I am telling, the pressure will always be same. That's mean P1 equal to P2 equal to P3. It must be same. I am taking the density as D, this height as H1, this height as H2, this height as H3, right? So different height. So P1 equal to, we can write H1 dg, P2 equal to, we can write H2 dg, because density is always same here and g is same, and this is we can write H3 dg. So you can see dg can be cancelled out. So we can write h1 equal to h2 equal to h3. That's mean these three height can't be unequal. That's mean they must be equal. They can't be different. So this picture is actually wrong. So what do we have to do to draw the correct picture? We have to make all the height similar. All the height similar. That's mean this will be the upper surface of the liquid. Is it clear? And this proves that liquid seeks its own levels. A nice picture is given in your book. Okay, so what is the picture? You can see the picture from here. Okay, different shapes are here. Okay, but when you are pouring some water, everyone is taking the same level. Everyone is taking the same level. Is it okay? Okay, so no more topic is here for today. Now you will find some extra experimentation processes there on another investigation that liquid has its pressure, and you can, this is something like that. Suppose a piston is here that is locked, and this is the liquid, and you are giving some pressure here, suppose lot of pressure. What you will find? You will find that sometimes this glass can break. If you give more pressure here, the glass will break. Okay, sometimes you have tried with the syringe. That's in the medical, with medical syringe you have sometimes tried this, right? When you give more pressure here, what happened? The needle which was attached here sometimes just gone away from it like a bullet. That's mean when you're increasing the pressure, it will just open up, right? And okay, so this is the basically proves that the liquid exerts pressure. And already you have done lot of project on hydraulic, right? In school's exhibition you have already done. So that hydraulic also proves that liquid exert pressure, and that is the example of the hydraulic press. Okay, whatever, so you know better than us. Now what shall I do? We shall do some numerical, we shall practice some numerical using this formula, different type of numerical. Okay, whatever, this is the end of the class. Thank you. Watch the full video, and of course don't forget to subscribe. Thank you.